planet Earth, home to over 6.5 billion human beings. Over the last 100 years, our species' appetite for energy has increased staggeringly. Exciting new technologies, funky gadgets and amazing machines are just some of the things which add to the energy we demand every day. But where do we get this energy? Most of the energy found on our planet begins its journey at the sun. As the sun shines down on the Earth, some of this energy is captured by green plants and stored. When these plants are eaten, some of this energy is passed on, and if that animal is eaten, it's passed on again. This is a simple food chain, providing the energy our bodies need. However, getting hold of this energy so we can use it to power technologies and machines can be tricky. We don't usually use the energy stored inside plants and animals alive today, but we do use energy stored in ancient animals and plants from the past. To find this energy, we don't need to go back in time, we just need to dig deep into the upper layer of our planet, the crust. If we dig in the right spot, we can find these ancient remains, but they don't look like animals or plants anymore. They have transformed into coal, or gas, or oil. We call these fossil fuels, and we can burn them to make the energy we need. But hold on, let's rewind for a minute. There's a few mysteries to be solved here. How do these ancient animals and plants change to become solid coal, liquid oil, or even gas? Also, why are they found deep underground? Why not lying about on the surface? It certainly would make them much easier to find. Part of the answer to these questions is locked up in the time it takes for them to change. In fact, the true age of many of these animals and plants is older than the pyramids, older than the last ice age, and in some cases older than the dinosaurs. Let's look really closely and find out exactly what happens to make them change from a living thing millions of years ago to a fossil fuel today. The first thing to realize is that not all ancient animals and plants become fossil fuels. In fact, there are 4 different things that must happen to an ancient living thing in order for them to transform into a fossil fuel. We call these conditions, so let's have a look at them. Let's examine them one at a time and find out what they mean, beginning with this condition, the need for a saturated environment. But what does saturated mean? Imagine a sponge. Dip it in a sink, and all of its tiny holes fill up with water. When the sponge cannot hold any more, we say it's saturated. A perfect example of a saturated environment is a swamp. This time, let's have a look at the need for an anaerobic environment. But what does anaerobic mean? Anaerobic sounds like a complicated word, but it just means that there is no oxygen around. Now, lots of living things, including you and me, need oxygen to survive, so we live in places where there's lots of it. We call this an aerobic environment. However, some living things, like certain types of bacteria, like to live where there is no oxygen. This is called an anaerobic environment. A great example of an anaerobic environment is in a swamp. Up next, let's have a look at the need for high pressure. But what really is pressure? Pressure is a force pushing down on or against something. A good example of a place with really high pressure is deep underground, where there's lots of rock pressing down. The more rock, the more weight, and so the more pressure. And finally, the need for high temperature. So, what exactly is temperature? Temperature is the measure of how hot or cold a place is. Now, we all know that the sun can make places hot on the Earth. but it's also very hot underground beneath the Earth's surface. This is because the Earth produces its own heat. An example of a really hot place is in deep mines. Okay, let's recap. This means for our ancient living things to turn into fossil fuels, they need a saturated environment, anaerobic conditions, lots of pressure, and high temperatures. Let's watch the whole story now, from an ancient plant to a lump of coal. Tropical areas provide the ideal conditions for plant growth. Millions of years before the dinosaurs walked the earth, the land was covered in early types of plants, mainly ferns. In tropical areas, these ferns were huge, gigantic tree ferns. At this time in the Earth's history, lots of changes were occurring across the planet. These changes caused sea levels to rise and flood the land, saturating the environment. As the water levels rose, small particles of soil and sediments were washed in. These gradually began to settle out to form a layer on the bottom. These changes transformed the area into a swamp, and over time it became more and more anaerobic. Without oxygen, the plants and trees died, toppled over in layers, and were then covered with water. Beneath the surface, in these anaerobic conditions, the plants, however, did not fully rot away, as oxygen is needed for things to properly decay. Gradually, layers of this plant material built up, and then sediments continued to wash in, forming another layer on top, a bit like a sandwich. When the water levels eventually dropped, these sandwich layers left behind were rich in nutrients, ideal conditions for new plants to grow. These plants then grew big over many years, and then the whole process began again. In fact, over millions of years, this process repeated over and over, like a cycle. So, in the formation of coal, ancient forests became flooded, and the rising water brought lots of sediments. These swampy conditions then became anaerobic and caused the trees in the forest to die. Layers of dead trees began to build up, and they were covered by sediments washed in with the rising water. In these anaerobic conditions, plants and trees could not fully rot. When water levels dropped again, layers of compacted dead plants, buried under a layer of sediment, were left behind, creating the perfect environment for new plants to grow. This process repeated over millions of years, and each time creating more sandwich-like layers of plants and sediments. As more and more layers piled up, both the temperature and pressure increased, pushing, squeezing, and heating the plant material to form coal. This process created the layers of coal that we see today when we dig underground in parts of Scotland.